Hello everyone, welcome to my lightning talk where I will introduce you to the superpowers of the Scylla shared-aware drivers. Before we start, let me present a bit about myself. I'm Alexis. I'm obviously French, as you can see by my accent. We've been using Scylla in production for quite a while now at Númberly, where I'm CTO. I've been contributing and sharing my experience with Scylla by blog post or in previous Scylla Summit sessions. So if it's your first summit, be very welcome. And I'm also involved in various open source projects. Let's start with a quick reminder, because while Scylla and Cassandra are both based on a token ring architecture, they have a major difference that we should highlight first. Let's start with how data is distributed and then located on the cluster token ring. On the physical layer, a data partition is a unit of data stored on a node and is identified by a partition key. The partition key serves to identify the node in the cluster that stores a given partition, as well as to distribute data across nodes in the cluster. The partitioner or partition hash function, which by default is murmur_hash3, using a partition key allows us to determine where data is stored on a given node in the cluster. On the Cassandra, the hash of the partition key gives you a token telling you which node has the data that you're looking for. We can call this architecture a shard per node architecture. So this is Cassandra. On Scylla, the same hash of the same partition key gives you the same token, but not only telling you which node has the data, but also which CPU's core is responsible for handling it. We can call this architecture a shard per core architecture. So you get the hash of the partition key, it gives you a numerical token, which leads you to a node, and then also can get you to one of its CPU core. This is a major architectural difference, and it has tremendous impact on client drivers' query routing design. So let's look at how Cassandra drivers leverage this. When a client connects to a Cassandra cluster, it opens a connection to every node of the cluster. Token-aware clients apply the partitioner logic on their side to select the right connection to the right node and make sure that its coordinator node is also a replica of the queried data. For this to work, the query must be prepared as a server-side statement so that our driver can know about the partition key of a query. This partition key is then seen as a routing key and used to determine which nodes are replicas for the query beforehand. So this is a client-side optimization. Token-aware query routing reduces query latency by optimizing the number of internal network hops that the cluster will have to issue before replying to the client. This is the most optimal way and default way of routing queries for most Cassandra drivers, but you have to remember that you have to use prepare statements. Please also remember that prepare statements, you should always use them, at least in production, because this is the safest way as well to query your cluster. It prevents you from injections. But Scylla can do better than token-aware query routing, since on Scylla a token can lead you to a node CPU core that has its name shard. So using the same query routing technique, Scylla shard-aware client drivers can route queries not only to the right node, but also to its right CPU core. This implies that instead of opening one connection to every node of the cluster, shard-aware drivers open a connection to every core of every node. Remember this one. The expected effect is even more reduced query latency and greater performance. Note that this is achieved with the same code from the client's perspective. All you have to do is change your driver name. So instead of on Python installing the Cassandra driver, just install the Scylla driver and you're good to go. Let's see how it's done. I'll take the shard-aware Python driver as an example because this is the one that I've been working on. Since most shard-aware drivers derive from Cassandra's, they tend to retain compatibility, and it's a good thing. So we apply this logic only if connected to a Scylla cluster, so that's the first thing we need to assess. If we are connected to a Scylla cluster, we then calculate the shard ID or CPU identifier, but keep in mind that it's called shard ID, from the partition key token. So we use the same token calculation logic as Cassandra, but then we do another calculation to derive a shard ID from this token as well. Now we find out if we have an open direct connection to the shard ID. And if we do, that's great. We'll route the query using this direct to core connection. This is the most optimal way to do it on Scylla. This is something that you can't have on Cassandra. If not, well, that's too bad. Let's try to open a new connection and hope to get connected to the right shard ID. So we just issue in the background another attempt to get a connection to the shard ID. And since we don't have a direct connection to the shard, to the right shard, let's pick a random connection to another one. That's still a token-aware query. So we are doing, in this case, even if it looks bad, we are still doing as good as Cassandra in this case. Since you're a careful attendee, you will have noticed that hope and luck are part of the implementation logic I had just explained. And indeed, hope and luck are at play currently in all shard-aware drivers because of a Cassandra protocol limitation. There's never anything bad with hope. We certainly don't want luck to be involved in our application's performance. But until Scylla 4.2, clients had no way to target a specific core while opening a connection to a node, and were depending on a round-robin allocation algorithm. So if you had multiple clients from the same source IP connecting to the same cluster, they would be competing and shuffling their possible way of getting a connection to every shard. This was not predictable. This made shard-aware drivers' performance subject to luck, and I don't want luck in my performance standpoint. I hoped for and worked on finding a solution to this problem with the ScyllaDB developers, which has come with Scylla 4.3 and is unlocking all shard-aware drivers now. Let's see how. Scylla 4.3 users can enable a new listening port, providing a new connection to shard allocation algorithm that is based on the source port of the client's perspective. So your client will have to select the right source port to target the right shard ID it wants to connect to. Then by pointing your shard-aware drivers to this new port, you will get a consistent connection to shards and even better performance that are not subject to luck. Using newer shard-aware drivers plus Scylla 4.3, you will always get a connection to every shard on every node, which got me to think about a nice punchline with Scylla 4.3, don't give up on hope, just give up on luck. I'm pretty proud of it. Before 4.3, this connection warm-up time was visible by the time it took to get the max performance boost on our application. This is a real graph of the impact on our production workload that the Scylla driver had. You can see that immediately we got 15% performance boost, but then since we didn't have a connection, our application didn't have a connection to every shard from the start, the more it was live and up and warming up, the more luck we got actually, and then we got the max of the best performance, up to 25% improvement in latency. So this is pretty impressive. What we expect with 4.3 is this. With 4.3, this boost will be instantaneous. You will immediately get the best performance because you will immediately get a connection to every core of every node. So for the full disclosure, this is a fake graph made from the previous one, but it's just so you get the idea. That's it for me. I hope you learned something today and that it was insightful and that you will try to use the Scylla shard-aware drivers, make it real. I mean, it's real at Númberly for quite a while now and the performance is great. So we are very much looking forward to switch all our production clusters and staging clusters to 4.3. Thank you very much.